Hello. Uh, Together with Shayma, we'll try to invite you to our thought process regarding how we design software in Creoox. Shayma is from Exoscale. Do you want to introduce yourself?
Yeah, thanks, Mateusz. So, hello, everyone. I'm Shayma, Cloud Solution Architect in Exoscale, public European cloud provider. And I'm really happy to meet you today in Wrocław, together with my colleague Eva. She's coming from Vienna, and I'm coming from Paris, just to join you in this event today. Thanks.
Yeah, and I'm Mateusz Milian. I'm working for Creoox. I'm mainly responsible for, let's say, this boring IT, so server, storages, deployment pipelines, all this stuff which is a bit far away from the problem which we try to solve in this hackathon. But at the end of the day, they are also important because we're talking about sharing data, sharing information. So we cross the boundary of one location. We have to transfer the data from one location to another. So those servers, networks are something which we all use. And that's why we want to also a bit give insight how we think about all this infrastructure, IT infrastructure stuff in such a way that we can simplify that. So it's all about trying to make this boring stuff a bit more exciting, but also a bit more simple to understand for everybody. And I thought that the good idea is to really based on real use case, and in this case is our journey to produce our latest IT system, which is xeoVision. The idea of this system is to utilize the power of Xeo SDK and provide very simple way to share BIM model to everybody, so you can just use the link and share with everybody who has access to this link. And yeah, I will just give very quick overview of how this really how the system really works. So, okay. Yeah, so it can read many different file formats. Let's try something like from the beginning. So we open the page, we take some IFC file. It will be very, very simple. It doesn't really matter what it is, but I would more focus on what it does under the hood. So in this case, yeah, it does something, but yeah, it just tail. But what is more important, we start from IFC file, then we did some conversion from IFC to GLB. We extract all the metadata from the model, and like let's say transform it to the XKT, which is native format of XeoKit, so we can really in an efficient way render this model in the browser. Of course, this was very simple. It's not needed for such simple model, but for very big one, this is quite important. And furthermore, we like see, maybe it's not very well visible, but you see all this step and you can access all the information. So you can track the whole process. What happens in which stage, you see what kind of version we are using. So all this is like tracked. So you have a traceability of this process. But yeah, so this all require quite, let's say, so from one hand, this system might seems quite simple, but from the other hand, you have a lot of like moving part, you have to put all this together. So designing something like that requires some preparation. And it's very simplified process, but what is here, but you're starting from, you have to have idea what you want to do. You have to like think how the system can be used, what's the how many users you expect to have, how many conversion, how costly is that, how many servers you need for that, because it might be that these are quite heavy operation, and if you get like 10 requests at a time, it can overload your infrastructure. So you have to think about this kind of stuff. You also have to take into account what kind of skill you have in your team. So you are choosing which tech stack, and maybe not at the end, but the next step is how you're gonna host this. So do you need like fixed infrastructure, because you have so predictable load that you can just say, this is what I need and I don't want to scale up, scale down, or you don't really know, and it might be that at one time you need like 10 servers, another time you need just one. So do you need this flexibility? Of course, in this process there are more challenges, but those are which are, according to me, the most important. And like next step, when you know what you want to do and what kind of non-functional requirements the system has to meet, you have to think about architecture. And here, how to do, because it's very easy to when you design IT system, it's very easy to overcomplicate stuff, because we have, as a software developer, I can say that we have a tendency to be like hype driven. We want to test that, we want to add this, and by doing this, not trying to control yourself, you build something which is not really suitable. It's overcomplicated for the problem. So you have to have idea what and why you are building. And for us, for the xeoVision, like two things was quite important. So one is the flexibility, because xeoVision, it's something which can work in different environments. So one way of distributing xeoVision is actually to provide this as a software as a service for the end user. But you also may have different use cases, and it could be used just as API, or it can be used as a part of the enterprise software somewhere inside the organization, or can be work for like directly for just one customer. So we have different environment for the same software. So it has to be somehow flexible. And the other thing, it has to be like ready for change in the future, because doing something like that, you cannot foresee all possible direction to the develop. And being more practical, we have to address two problems here. One is that you need to queue the job, because if you have a conversion which is quite costly process, it might be that you don't have at a particular moment in time enough resources to handle everything in parallel. So that's one feature of our system. It has to be able to queue the jobs in effective way. And another one, which is quite noticeable, is that we here work a lot with the files. So IFC is a file, logs are files, XKT is also the file. So everywhere we work with the file. So those are like two quite important aspects which we had to take into account building the architecture. And now, I don't want to focus too much. We have a few components. That's the xeoVision from like the architecture diagram. What I want to just show that we have this element when there is a storage, because we work a lot with the files. We have to abstract this, because someone maybe if we deploy to some customer, they have their own storage and they want they don't want to use our. So that's one case. It's like a separate component, and another one is converter. So this is like very abstract component which can do different types of conversions. So from IFC to GLB, from GLB to XKT, can do some validation. So here, all the possible like conversion processing is in this component. This API in the middle is just something which orchestrate, makes sense of the data and provide the data to the user, to the browser. This is about our tech stack. So at the top, we are utilize the whole power of XeoKit SDK. On the bottom, we have infrastructure provided by Exoscale.
Yeah. So once you figure out your modeling solution, in that case, it's xeoVision, you need to host it somewhere. It for sure won't be on your local computer. You need to share it with people. And this is where the role of public cloud provider Exoscale comes. So as any public cloud provider, we do offer different service. One of them is the one that Mateusz mentioned, which is SOS storage. So it's simply a storage service. It's like Google Drive, where you can drag and drop files, photos, videos, etc. But it's more dedicated for businesses and developers to host their data, to host the log of their applications and simply files so that they can integrate it with their solution. We also offer managed database, so database like Postgres, MySQL, OpenSearch, and so on, and the list goes on. It's simply that you have the advantage of open source tools. So in Exoscale, we are made of open source, and we encourage our users to use open source tools. So you have all these advantage of database like Postgres or MySQL or whatsoever, but without the hassle of doing backups, of auto-upgrade the version, or even of scaling. For example, if you have a need of more CPU, memory, storage for your solution that you have developed. Also, we do offer computes. So those are simply virtual machines that you can scale up and down depending on your needs.
Yes, so we are back to this decision process, what to use, and now we are on the infrastructure part, in the infrastructure. And then what was important for us is that our infrastructure has to support our architecture. So they are like aligned. So we don't use something which is meant for our use cases and not use the services which are simply cool. Yeah, and the other quite important factor for us is actually automation, that we can automate out as much as possible, as it was mentioned on other presentation, that they try to they do the model check in an automated way. The same is with infrastructure. The more human is involved in this process, the more likely is that we'll make some mistake. Here, there is also, when you like trying to choose where you host your stuff, we thought about all this cognitive load. So right now you have like plenty services, cloud providers, all this tech stuff, and it's coming every day, it's something new. And this is very specific per this provider or for this provider. So for us, it was quite important that we only use those things which we like understand. And let's say each developer in our team also understand what part of the like services, third-party services we are using. So at the end of the day, that's our building blocks. It looks that there is a couple of them, but actually it's not so much comparing to other projects. So we distribute all our software as a Docker images, and these images are hosted on compute instances, which are simply virtual machine, which are simply the server, but virtualized on the physical hardware. So there is no big difference between like traditional server compared to the there is no big difference from the developer perspective. They don't even know that there is...
The only difference is the ease of use. For example, when you are using cloud, I'm trying to simplify to the maximum, you need a virtual machine or a server where you will be hosting your code, the code of your modeling solution, xeoVision, for example, and therefore you don't need to buy a server or do any maintaining stuff. You just go and rent some virtual machine from cloud provider, and this is totally easy and doable via your browser or internet.
Yes, and I mentioned this Docker containers, and just for people who are not familiar with this technology, the whole idea is that you isolate your process. So everything what you run in your computer or in the server is some kind of process, and it has a certain level of isolation. When it comes to the Docker, it guarantee a bit bigger level of isolation. It's its own like namespace, own place on the server. That's one thing. This is from like infra point of view, but from the developer point of view, you work with the Docker container as you would work with the like whole operating system. So you can provide there all the dependencies which are needed. So it's quite convenient. And like the cool part of that is using just this, you can compose pretty sophisticated services. So you can compose many of Docker containers together, and they create the service which can do many things. I can now do a quick demo of our xeoVision, but not from the like UI perspective. So I will not use the portal, but I will try to use from the API point of view. Because as I said at the beginning, xeo.vision can work in very different setting, in different environment. It can be used for different use cases. And one of this is to provide this as a service, as a web service, and everybody can actually having access, etc. Can use it and can utilize for their own purpose. So, okay, can you read what is on the screen? Okay, so for this presentation, I built very simple TUI application, terminal user interface, which is actually the very thin wrapper on top of the Xeo services. And this exposes different possibilities which this service provides. So let's say we want to convert the file. We, let's say, choose the file. This file now will be uploaded to our storage. It's a small file, it will be just in one chunk. Then you see that this whole processing, so we process from one format to another, and it provides us like link to the model. It actually could open it, but I didn't want to. But if I copy this one and paste here. Yes, I should be able to see it. Yes. So this is just for check if this all working fine. But I also have all other information which could be useful for me. So if I like. I have all the logs from all these steps, etc. And this is all built in a few hours on top of our API. So I can see which converter actually was used from IFC to to GLB, what kind of log. So here we see that we have version 4.18. This all is available directly from API, and it's meant to like extend xeoVision for your use case. Yeah, so that's basically what this is about. Yeah. Okay. So I will provide also the links. If someone wants to try, it's already possible. There's still beta version, so a lot can change, but we want to release it already to publicly to also get some feedback, what you think, what you can build. But the whole idea is that we already provide you, together with Exoscale, the storage, so you can store those files quite easily. You just need to upload. You have a special link, and you can use for other purposes. And then you have a set of different operation in this second service xeoVision converter, and with this you can play and build your application. The number of the operation will grow definitely in time, so you can have a validation of IFC file, etc. So that's about the IFC. And coming back about to this boring stuff, Shayma told that we use here managed database, so quite well-known relational database, which is Postgres in our case. But what I wanted to show, just to give you like glimpse what it means to deploy production-ready database. Here is like the snippets. That's the full, let's say, code which is required to manage this database. Unfortunately, it's not clearly visible, so I cannot really tell you what exactly is there, but it's just 10 lines which are pretty easy to understand, and you have a production-ready database, so you don't have to do a lot of stuff. And now, the second problem which we had, like queue the job. Yes, so if we have a congestion on the line, so we have more and more models to process, we introduced here the concept from Exoscale, which is instance pool, so we can dynamically add server as we see that our queue of conversion is growing. Yes, so this is another thing, and again, nothing very complicated. Yes.
There is also the concept of custom template. For example, when you want to deploy your solution on a server on Exoscale, in that case xeoVision, you know, for example, that you need some specific tools on the server instead, like, I don't know, Java, Python, or whatever tools that you need or plugins that you need on the server. So you create your server on Exoscale, you install those tools on the top of it, then you create a custom template or what is simply an image. It's like copy-paste so that you have every time a ready environment where you will be hosting your solution, but with all the prerequisites that you will need to develop this solution. So this is the concept of custom template. It's simply having a pre-configured server with defined prerequisites for your solution.
And now going back to more general ideas. So how to achieve simplicity in IT infrastructure. So one of the tool which we are using here is that each developer has to understand all the pieces, how they work together, and they can actively work on them. This enforces the thinking that you cannot really use too sophisticated, too complicated solution, because then you cannot really explain it easily to everybody. And furthermore, let's say our rule is that even production-like environment, you can run on your own laptop, assuming that you have enough resources. So we don't have anything special even on production. You can emulate everything on your developer machine, and this gives you from one side some constraint, but for other side, everybody understands everything. So if you have a problem, you don't understand why you have this bug, you can easily, or not always easily, but you can reproduce it locally. Another thing which we try to like use, it's limit number of tools and services, especially third party we are using. Because yeah, every day there is a new DevOps tool, platform tools, new service from cloud providers, and you cannot really keep up with all these things, especially in most cases then they don't add more value, and definitely they add complexity. And then almost everything, but if something is very costly to automate, then leave it as is. Don't try to go for 100%. Then the last bit is having the infrastructure which is reliable, and if you spot the edge case and you need some support, you have a support from the human, not from the AI, because that's the most common support which you get these days.
You will get support from me, from my team, from our support team also, which are not chatbots. You will also get support from beautiful ladies like Eva. So yes, we are a bit quite reactive to help you to solve any technical problems on any platform, and to help you to get familiar with our platform and make your life easier.
Yes, and other factors which we also thought a bit. So if you go too deeply into very sophisticated cloud infrastructure, you need to hire someone who will manage costs, because cost of cloud very fast grow to the infinity, and we try to avoid lock-in, so we just use open source stuff. So if this solution, this provider doesn't suit our needs anymore, we can easily switch to another. By that we also avoid too much, cloud provider specific lingo, language, and we also try to understand all the data flows, because especially in very all this big system, you don't really able to trace where your data flows, and in many for many our customers that might be very important. That might be very important factor.
So as a developer, the most important for you is to deploy or develop your solution, to host it somewhere, and to be able to predict the cost of what you are doing without having any surprises or other expenses like on other cloud providers. Plus also to not be locked in. Means if tomorrow you are not happy with one specific cloud provider, you can simply take your solution and deploy it somewhere else because of cost issues or technical complexity or whatever. And this is why this is what is our DNA actually. We try to provide prices that are straightforward, cheaper, but also a platform that doesn't lock you in, since we are built from open source. So you are free to go whenever you like, but I'm sure you will be happy in Exoscale.
Thank you. Are there any questions?
No news, good news.
Yeah, so thank you very much for this time. If you have any question, just reach us, me on Shayma. We can give you some more information. I can share the code.
One question.
It's not a question. Oh, I just wanted to say that we, competitors already, I hope, know, but just in case, in the group we posted a coupon, so you can use it for this competition. It's created for this competition. And if you need any help, we are sitting there. So, yeah.
Also, we have some gifts to provide for the winners. Also, these mounties that came with us from Switzerland, inspired from the Switzerland mountains, will be your new colleague. So good luck, everyone. Thank you.
Thank you very much. Thank you.